Hello students, today we are going to discuss about circle chapter number 10 of 9th class. So circle, every day we see many things which is in the shape of circle, like coin, bangle and lots of anything. Few properties and few theorems related to circle. So let's continue with circle. A fixed point, and from this fixed point at a fixed distance, take care all these points should be at fixed distance, and when we join all these points or collection of points from a fixed distance, we obtained a circle. This point known as center of circle. From center of circle to any part of its boundary, that is called line segment. For line segment, but when we talking about circle, then it have a specific name, that is radius. Radius of a circle always equal, and when extend this radius and join other part, then that will act as diameter of circle, or longest chord of a circle. Longest chord of a circle. Now come to the chord. Chord, a line which not pass from center of circle and join one point to other point, that is called chord. But if a line pass from center of circle to join its boundary, that is called diameter as well as longest chord of the circle. Some more terms related to it, like a part of its circumference, that is called arc. Shorter circumference is called minor arc, and remaining major arc. So shorter length or smaller length, minor arc, and longer, that is called major arc. Now come to the next point, that is segment. Area enclosed between chord and arc. Area enclosed between chord and arc, that is called segment. Particularly this is in smaller part, so we can use a specific word, that is minor segment, and remaining part major segment. Other part is sector. The sector area enclosed between radius and arc, that is called sector. Smaller part of whole circle, a specific word, minor sector, and remaining part major sector. A circle divide plane into three parts. A circle divide plane into three parts. How? Interior part of the circle, on the circle, exterior part of the circle. So a circle divide plane into three parts. Inside of a circle is known as interior, on the circle, and outside the circle, that is exterior. Now let's continue with some theorems related to chapter circle. So first theorem is angle subtended by a chord. Angle subtended by a chord at center. Suppose we have two circles with same radii. Two circle with same radii. In both circle, AB is equal to CD and both circle with same radii, then angle subtended by this chord at center equal to each. So in this question we have to prove angle 1 is equal to angle 2. Angle 1 is equal to 2. Now the question is how we can prove it. What we have first of all in this we have AB is equal to CD. What we have to prove? To prove angle 1 is equal to 2. How we can prove it? Let's see. In triangle AOB, and triangle COD, in triangle AOB and triangle COD, by using congruence rule, if we prove these two triangles congruent to each, then easily we can say its corresponding angle equal to each, therefore 1 is equal to 2. But first of all, how we can prove it? So AO is equal to CO and BO is equal to D O dash. Why? Equal radii. Both circle with same radii, so definitely radius of both equal to each. And what would be third in these two? That is AB is equal to CD, which already given. When we prove these three things, by the way, all three sides equal to each, so these two triangle congruent by each. Triangle AOB congruent to triangle COD by side. So by SSS, these two triangle congruent to each. And when we prove two triangle congruent to each, therefore angle 1 is equal to angle 2. Why? By CPCT. By CPCT, the corresponding part of congruence triangle. So corresponding part and corresponding angle, when we prove two triangle congruent to each, then their corresponding side and corresponding angle which not given equal to each, then definitely equal to each when we proved congruent. So finally angle 1 is equal to 2. Therefore if chords equal to each, then angles subtended by these chords at a center equal to each. Now next theorem is reverse of this, converse of this theorem. This one, theorem number 10.1. if you check 10.1 and 10.2, what in 10.2? In 10.2 we already given angle 1 is equal to 2 of two circle with same radii. If angle at a center is equal to each, then chord subtended by whatever chord we will obtain by those angle, that will also equal to each. How? Let's see. Now again we have to draw two circle with same radius, and now we have angle at center which we proved in previous question is equal to each. Now we have given. So what we have in this given, let angle 1, angle 2. So angle 1 is equal to 2 given. What we have to prove in this, now in this case we have to prove equal angle subtend equal chords. We have to prove AB is equal to CD. To prove AB is equal to CD. Now again same case, if we prove these two triangle congruent to each by any congruence rule, then AB is equal to CD. So again we have to prove these two triangle congruent to each. How? In triangle AOB and triangle CO'D, AO is equal to CO dash, BO is equal to DO or OD dash, equal radii. And third is angle 1 is equal to angle 2, which already given, right? So finally these two triangle, therefore triangle AOB congruent to triangle CO'D by side angle side, by side angle side congruence rule. Now finally we proved these two triangle congruent, therefore its corresponding side AB is equal to CD is equal to each by CPCT. Why we are using here corresponding side? If I cut this triangle from here and put on it, then exactly which side covered to this one? So AB, side AB covered CD. That's why we're using a word corresponding part of congruent triangle. It means one we prove two triangle congruent, and when we superimpose to each, which part coincide with the other triangle, that will be considered as a corresponding part and corresponding angle. Now come to the next theorem, theorem 10.3. Theorem number 10.3. And theorem 10.3, what about theorem 10.3? In this theorem, a circle a chord AB. Theorem 10.3, according to theorem 10.3, if a line from center of circle to a chord, if a line from center of circle to a chord that is perpendicular, then definitely this line bisect the chord. Let this point M and center of circle O. A line from center of circle to chord perpendicular, then definitely it will bisect the chord. Therefore, we have to prove in this, to prove AM is equal to BM. AM is equal to BM. Now again, how we can prove it? What we have in this, we have OM perpendicular to AB given. So whatever we have, with the help of that we can't prove it. Some construction required. What are those construction? By construction, join AO and OB. Join AO and OB. If we prove triangle AOM, if we prove triangle AOM and triangle BOM congruent to each, then definitely AM is equal to BM. Why? Corresponding part of to congruent triangle. So in triangle AOM and triangle BOM, in triangle AOM, AO is equal to BO. Why? AO is equal to BO, radii of the circle, a radius of a circle equal to each. So radius of circle. Second thing, let this one angle 1 and angle 2. So angle 1 is equal to angle 2. Why? Each 90 already given. What would be third? Third is OM is equal to OM. OM is equal to OM, that is common for both triangle. So finally, to prove two triangles congruence, we have 5 congruence rule. Any one should be exist here. So by RHS, R right angle, H hypotenuse and S side. So by RHS, these two triangle congruent to each. Therefore, triangle AOM congruent to triangle BOM by RHS. Once we prove these two triangle congruent with each, therefore their corresponding part, corresponding side is equal to each. So AM is equal to BM. If AM is equal to BM, then we can write, yes, OM bisect AB, or a line from center of circle which make right angle with chord that definitely bisect the chord. Okay, so for today that's all, and the remaining part we will continue next time.